Great. Thank you very much for the introduction, Jamie, and good morning, everybody. It's wonderful to be here in Adelaide. I had a wonderful day yesterday at the Geological Survey Open Day, and it's a pleasure to present again on the Resourcing Australia's Prosperity Initiative. It's the largest investment in pre-competitive geoscience ever in Australia's history. So what I just want to share with you today is what is that going to look like. But before I start, I do want to acknowledge that we're meeting on Kaurna land and pay my respects to elders past, present and emerging, and any who may well be in the audience today, and acknowledge that they are the first mappers, miners and navigators across Australia. It's clear that the demand for critical minerals and for clean energy is just accelerating. We know that these markets are extremely concentrated. We've heard about that from Bronwyn this morning. We know that there's a lot of national security concerns that are growing across the world, and the drive to the net zero transition is real, and the minerals that go into these have increased by 250% in terms of demand over the last 2 decades. So this is the opportunity that the Australian government sees for Australia. One thing that's interesting is to have a look at, do we have enough resources to meet these demand? So if you take Australia's share, which is shown in that yellow kind of hash box, this is all of Australia's economically demonstrated resources that we pull together from publications on the Australian Stock Exchange and some non-listed companies, if they let us know what they've got. And then the blue bar, that shows if we look at that from across the whole world, from the data that the US Geological Surveys or the BGS has. And then we look at the International Energy Agency's forecast. So there are stated pledges, there is the announced pledges, and there's also what is required to meet net zero. And you can see that under most of these scenarios, there actually isn't enough discovered so far to meet the demand of the future. And it's also unrealistic to think that we're going to actually develop all of the resources that have been previously defined, because there are other challenges to resource development, such as geopolitical stability, ESG issues, and so on. So the opportunity is huge here. One way to look at this is just to focus on the battery minerals. The forecast for their use is enormous. And if we just do a really simple thought exercise, in the middle column is how much Australia earns from exports of these minerals. They are less, broadly speaking, than what is currently being used in green tech and energy. And if you just multiply by those factors, you can see that by 2040, these industries can be massive. But that's such a short period of time for us, to get various deposits up and running and the like. So that there is a real need to identify and discover deposits that we can responsibly develop. So what are we doing about this? Well, in May, at the budget, the federal government announced the Resourcing Australia's Prosperity Initiative. That's $3.4 billion over 35 years to invest in pre-competitive geoscience, into geophysics, geochemistry and the geology for minerals, energy and groundwater resources. Effectively, we're trying to strengthen the renewable energy strengthen the resources sector, promote the renewable energy transition, provide a platform for innovation across the country, and importantly, empower communities, including First Nations, with geoscience knowledge in order to be able to make the most of our resource endowments. Over the last, so what are we doing about this? At the moment, we're in the process of consultation and building a roadmap which will be released early in the next calendar year. We're planning it over the next 10 years, and the spend over that time is $566 million. We started consulting with our state and territory counterparts, such as the Geological Survey of South Australia, and from that we took, I suppose, a straw idea in terms of what we might do across the country to 23 external consultations across the country. We had an open survey where we got 77 responses, predominantly overwhelming from industry, tens of additional individual consultations, and in all we had about 400 individuals participate in the feedback over this time. So the consultations were focused on 4 interrelated components. The first one is Australia-wide geoscience datasets. These are the foundational building blocks to understand what is on and below the Earth's surface. And the aim here is to increase the coverage and the quality of these datasets of geology, geochemistry and geophysics. We then take those information and we understand the national resource potential. So these are providing an inventory of where are the best places to go and explore. So industry uses these, government uses these for land use planning decisions, and they also help with attracting investment into the country and have been shown to work. But we can't do everything at that national scale. There are lots of places where we just don't know enough about the geology. So we intend to go into areas of unrealised potential, may well be in complete frontier greenfield areas, or may well be the extensions of known provinces. There was a bit of a debate during the consultations about that type of mix. And we will do deep dives. We'll go in with a view in terms of accelerating critical mineral resources in those, but when we're there, we're going to assess all the geology in those particular areas and all of the potential resources. We saw the wonderful series of talks earlier today where when we go into the region, we find things that we just did not know about. So this is the power of understanding all of the geology across those particular regions. And the last theme is data and engagement. In this particular area, we recognise that the way we deliver our data sets and engage with our stakeholders is just as important as the geoscience that we collect. Unless you can access it and know what we came up with, there is not much point in actually doing it, because we're here to support industry and communities across Australia. So what I'm going to do now is I'm going to go and provide you a little bit of an example of these. They're going to be a little bit different to what I went through yesterday, and we're going to start off with Australia-wide datasets. But I have to show this one. It's an amazing new dataset across Australia. SAEMC, 20 kilometre space flight lines. We're imaging conductivity down to 300 to 400 metres. When we started this, we were called mad, and now across all the consultations, everybody say, please just finish it. Fundamentally, it has de-risked this technique and its applicability across the areas of Australia so that people can go in and undertake higher resolution surveys, and it is useful for minerals, energy and groundwater. Notice there is a big gap across South Australia, and that's what Resourcing Australia's Prosperity is trying to fill. We want to complete this data set across all of Australia. Now that's looking at effectively the very near surface down to depths of a few hundred metres. We can go to the other extreme. We know that the lithosphere controls the distribution of resources, and over the last decade or two, we've been learning that the lithosphere-asthenosphere boundary has a greater predictive power in terms of concentrating the distribution of deposits than, say, the MOHO, the next major kind of interface across the country. We released a data set like this 4 years ago, and we showed that the distribution of sediment-hosted lead, zinc, copper, IOCGs in Australia and globally is controlled by the transition from thick to thin. What you're seeing here is a revision. We released this year. It is now sharpened up, this image, and actually by embracing uncertainty. By embracing uncertainty, we'll actually start to resolve features a lot better, and we'll also be able to quantify what that uncertainty is, and that's the purple map next to it. How have we done this? We've done this actually by going after these really rare rocks, the kimberlites and so on, which pluck up mantle xenoliths and xenocrysts, which allow us to calibrate the geophysics that we collect into a thermal model to map the lithosphere-asthenosphere boundary. It's just at a point in time. A lot of these were stored in various people's garages and maybe lost to all time if we hadn't moved at this particular point. And we've also developed a whole bunch of maths and so on behind this at the Australian National University. But the big transition to all this is going to be when we complete the AusArray survey. So at the moment, we've got seismometers out across the whole country, spaced about 200 kilometres apart. They've already been in there for about a year and a half, and we'll be pulling them up at the end of this financial year. So within a year or two after that, we'll be releasing the new update tomography models of Australia, which will result in major step changes. What we want to get away from is uncertainties in terms of what are the data sets that have gone into this, where are the places that are certain or uncertain, and we're going after that fundamental tomography. And these are techniques that are similar to what Anthony's going to be talking about in Fleet, but on that scale at a very much shallower level. So you're seeing the rise of passive seismic applications. But we don't just, I suppose, do geophysics. We try and interpret and extract geology out of it. So we try and understand what is the geology and map it across the whole country, which is a fundamental input into national resource potential studies. So we've got maps of the Cenozoic, Mesozoic, Paleozoic and Neoproterozoic, or at least what the geology sits beneath those major unconformities across the country. And we're working at the moment in terms of what is the depth to those particular unconformities as they fundamentally control the undercover search space and the economics of that. So moving on to national resource assessments. We have a commitment as part of the program to assess all 31 critical minerals across the country, the 5 strategic materials, places that are suitable for geological storage of hydrogen and carbon, and also sites that are suitable for offshore renewable energy, effectively the positioning of wind power offshore. What we have been doing across the time is using a mineral systems approach, and we're certainly not going to abandon that. We're going to continue to advance our understanding of these systems and work out how we can map them and how can we feature engineer predictive layers to be able to do that. So you come up with the heat maps that you can see here. There's one here for iron oxide copper gold, sedimentary roasted copper, tholeidic nickel copper PGEs. All of these have copper in them, so you need to combine all of these to come up with a copper potential. But naturally, we don't have porphyry copper here, we don't have VHMS and other systems. So to come up with a copper system map, we need to finish those other components. So we're not going to be abandoning that. That's how we're going to keep going. We'll also be looking at mine waste potential, especially for the 50% of critical minerals which occur as co- and byproducts exclusively and occur in very low volumes. So that's where the opportunity in the mine waste space may well be. Now, to develop resources across Australia, what we need is water. About 60 to 70% of mines rely on groundwater as the water source, and it's a key concern in terms of communities, in terms of development. So what we're doing is we're going around the country, hydrogeological region by hydrogeological region. We're compiling all of the information that's there, standardising the stratigraphy, paying great attention to the biostratigraphy and the continuation of sediments across these various jurisdictions. And we actually started in Katithunda, the Lake Eyre region across Australia. This is, I think, probably the first indicative groundwater map levels for the entire basins ever produced. It's amazing. I highly encourage you, if you're working in that area, to look at these reports. Now, in addition to the geology bit, which is kind of where we're safe, you know, that's kind of a core business, we realised that we also need to bring in that economic component. So we developed a tool called Economic Fairways. It's a form of techno-economic modelling in partnership with Monash universities. It's won a whole series of different awards now, and here's an example of economic fairways for hydrogen. We also have this for copper, gold, lead, zinc, and so on, and we'll be developing these for other commodities. It shows you the places where you can economically develop a certain type of resource, in this particular hydrogen. For hydrogen, it has information such as wind loads, solid capacity factor maps, what is the best distribution of mixes of batteries if you're going to use that information for other manufacturing purposes. And in this particular case, what I'm referring to is green steel. If we're going to decarbonise our industries, certainly the generation of steel is fundamentally very, very important. And some work by Marcus Haynes and so on. We're effectively comparing the cost of green steel manufacturing between the Pilbara and the Eyre Peninsula. You can actually see the Eyre Peninsula is slightly more economic, and that's because you need to invest less in storage of the hydrogen in those particular areas. The two red bars that you can see on here, the bottom one is the current cost of steel production across the world, so you can see green steel is more costly. But the top red bar, which we're beneath, is if you take into consideration the carbon adjustment to exporting to the EU, which is about to come into force. So we're somewhere in between those two, and the thing that we think we can do best in terms of reducing these costs further is actually to lower the cost of hydrogen storage by an order of magnitude, and that is by identifying suitable places for salt. So these are caverns of salt that you can drill into, dissolve out, inject the hydrogen into it, and the economic fairway map here shows that what would be the effect if we were successful in developing hydrogen storage in the onshore polar basin where we know that there's salt offshore in those regions, and there are companies now looking at that in South Australia as a viable opportunity. And we saw in the talk by Carmen earlier today all the work that's happening in terms of magnetite resource definition, which is needed for green steel manufacturing at the moment through hydrogen. All right, so moving on to deep dive regional projects. So these are areas where effectively we're now zooming in and we're validating the national work that we've done, and we're answering very specific questions. They are areas of potential, often undercover, and in those regions we do additional data collection. And what we're talking about here are things like reflection seismic profiles, infield airborne electromagnetics, and fundamentally testing our geological knowledge using drilling, such as we've been doing with the MinEx CRC through the National Drilling Initiative. So we want to continue doing that type of work in the deep dive regions. We're finalising what they are, and they'll be released as part of the first 4 of them were released as part of the roadmap, but 2 have already been revealed. So we've worked out that we've been previously in a 4-year kind of cycle of funding, and the deep dives just take us longer to do than that. They take us about 6 to 7 years. So we're going to be continuing for a few years in the Delamerian region, working with the Geological Survey of South Australia, pulling together the information that has come from both National Drilling Initiative projects across New South Wales and South Australia. Yesterday, Tom Wise gave a great talk on the interpretation of the deep reflection seismic profile that goes all the way from the Torrens Hinge Zone out to the border, and the interpretation is out there. He effectively shows the Neoproterozoic sedimentary basins there are over 10 kilometres thick. Beneath that, which you can see, is a sampling campaign that we did as part of the Exploring for the Future program of sampling basalts across the region. This is Dave Champion and David Houston, and we're comparing it to a similar type of work across Mount Isa. What we find here is that when we compare those 2 regions, that Mount Isa has much more variability. It seems as if the fluids there were more potent, and they've stripped copper and zinc. In the Stewart Shelf, the copper is indeed stripped, but the zinc isn't. If you have a look, the copper's kind of stripped to, on average, about 60 to 70%. If you think about the distribution of the Stewart Shelf across the region, and you do some numbers, it's probably about 1 billion tonnes of copper that has come out of these mafic rocks across the Stewart Shelf. Now, if we have a look at the largest deposits there, in terms of the sedimentary hosted style, they have about 0.1% in each one of them. So the copper's gone somewhere. And the question is where, and those are the types of questions that we want to be asking as we do deep dive projects. So delivery, awareness raising and engagement. So this is where we're going to be focusing in terms of how do we deliver. So we're really keen to hear your feedback on that. But it's important that we also develop relationships and partnerships with the communities where we're working. We've been doing this with First Nations people as part of the Exploring for the Future program, sharing knowledge, for example, of soil mapping, of groundwater chemistry analysis and the like. We want to continue doing that, especially within the deep dive regions where we'll be working out into the future. Now, the way that we've been delivering data sets, the feedback that has come back from those consultations is like that, your tools are great, some world leading, but they can be a little bit more intuitive in terms of how to use. So we'll be focusing more in terms of human-centered design and making them function better, both for the subject matter experts, such as most of you in the room over here who kind of want the raw data or the direct interpretations of what they mean. But there's also a whole group of users, so communities, people in government, decision makers who just want to know, so what did you find? What's the end point of all this work? And that's where a tool called Geoscience comes in, where we've been working out how to subdivide Australia into a whole series of regions and maintain updated information of the resources in those areas, and also what is that we understand of the resource potential within those particular areas. So I encourage you to have a look at that. Right, so what difference does all of this work make? To answer this question, we commissioned a study by Deloitte Access Economics, who went around and looked at some of the studies where we've been going around asking companies, do you use pre-competitive geoscience at a number of different conferences. So this is without bias, just going to a conference and going to every booth at that particular investor conference and asking those questions. What we found is that about 80% of Australia's explorers acknowledge that they rely on pre-competitive geoscience as provided by the state and territory geological surveys as well as ourselves. We always work in partnership, so we can't disentangle those two components. And the study did not look at coal, did not look at iron ore, but was able to identify that the pre-competitive science that we provide supports about 3.5% of GDP across the country. And for every investment of $1, downstream value adds about 1,000 times fold. That's staggering. We've been trying to track the use of the information, and we've had David Upton working for us, and he's keeping an eye on the tenement map of Australia, and he calls up companies. Thank you very much for those of you who have been speaking to him. And he asks, oh, why did you pick up this tenement? What data sets did you use? And over the last 8 years or so, he's been able to collate that there's been about 160 companies exploring by over 1,300 tenements covering more than 500,000 square kilometres using the data sets that Geoscience Australia, in collaboration with the states and territories, is providing. And that level of activity is actually making a difference. So you might cast your mind back to the initiative called Uncover. We're trying to unlock the undercover search space across Australia. We were worried at that time because Australia was losing its market share of mineral exploration. We're at a high of 23% in 1993, and we went down to an all-time low of 8% in 2015. The Exploring for the Future program started in 2016, and since then we've been going up and up. I think that this is because we're starting to unlock the undercover search space, because when we asked companies, why did you leave back then to explore elsewhere around the world, the answer was, well, the undercover is just too hard. How do you do it? What are the data sets? How do we go about it? Well, activity is great though, so how are we performing though? So one thing to do is to go and ask Richard Shoddy for his latest download of global resource discoveries, and the majority of value is housed in Tier 1 and Tier 2 deposits. Since 2017, there have been 41 of these discoveries globally, and 10 of them have been in Australia. That's an amazing proportion of these world-class discoveries in Australia. Now, these will change as companies kind of report, and we find out what happens in places which don't report very well. But a really interesting thing is, when you go into the discovery stories of each of those 10, 7 of those, the choice to either go into the region of where the exploration, where they went into, or how they operate within that area has been supported by government geoscience information. That is remarkable, I think. If you're interested, what are they? These ones that have been supported by pre-competitive geoscience. This is a list from across the world. There's a few that I'm still following up discovery stories, haven't been able to find. There's about 6 or 7 internationally. But you can see the list in Australia. And what I find amazing here, there's a few points. First of all but one of the deposits in Australia that have used this type of information have been found at deeper levels than all the others across the world. I think you're seeing that we are rising to the Uncover challenge, and we're actually reaping its rewards at the same time. The other thing that's interesting, the variety of deposits of the metals that we're discovering is quite large, but there is a common element to this, and that is gold. You know, when you go to something like PDAC or those kind of types of conferences, there are often talks there. Gold, the critical mineral. Well, it's not critical. It doesn't quite fit the definitions of, but it's certainly an enabler. It will certainly help the projects going. So we're mindful that gold is an important component to continue to support as part of the pre-competitive information that we provide. So the future, I think, for us as a geological survey is bright, and for investment across the country. And we look forward to working with you into the future. So thank you very much.